Right. So I have shared my whiteboard and I guess you guys are able to see it, okay? So Vishal, first I would like to give you a quick recap of what we were discussing yesterday, and then I'll talk about the things we need to cover today. Okay. We were talking about volumes of revolution. There was another thing which we discussed yesterday that was about improper integrals. So I'll share the recordings. You can cover that to the recordings. But this is important, and since we need to discuss this again, so I wanted came up to the basic recap. Okay, volumes of revolution. What exactly are we doing here? Now you must be thinking that we were doing integration, and by now all you know is that whenever you integrate a curve, that gives you area under the curve. So what exactly is going to give you the volume of revolution? What exactly is this? So I'll tell you, okay? Let's say I'll make a curve. This is the y-axis. This is the x-axis. And let me just make a graph quickly. Okay. So let's say the graph is something of this type, okay? And you are integrating it from 2 to 5. This is the area that you will get once you are done with the integration. The equation of this curve is y equals x squared. And yeah, that is it. Okay. Now you know that in order to find this purple shaded region, all you do is you integrate from 2 to 5, you write down x squared, you write down dx. Any confusions in this, Munja and Ashal? Are you guys comfortable with this? Are you guys familiar with this concept? We have been doing this already.
Yes, ma'am.
Okay, Ishal, what about you? I'm giving this recap for you, okay? So please confirm. Okay, very good. You know this. Okay. Now, Munja, please pay attention. This is the first thing. And now if I make another diagram, so for that, okay, I'll make that here. One second only. Please just give me 1 second. Okay. And what if I make the same curve, but this time around, these are the limits. Okay. Now, this is also an area, but this time around, this area is bounded between the curve and the y-axis. So what exactly do we do here? Again, the equation is y equals x squared. It is not new. All this is old. This is what we have been discussing already, okay? Now, if I'm interested in finding out this purple region, what am I going to do? I would certainly integrate from 2 to 5, okay? But this time around, we are going to have what? Can anyone tell me? We'll be having dy because it is between the y-axis and the curve, and the equation would be x equals something. Okay, so I'll make x the subject, and that would give me under the root y, and this would be the integral for this. The integral for this would be 2 and 5. It would be dx. Now, please listen to me. If it is dx, I would want that the equation is in terms of x. That is, it would be y equals something. So I'll make y the subject and I'll write down this thing over here, that is x square. And these scenarios are your go-to scenarios. You always have the equation in this form. But for these cases, when the area is bounded between the y-axis and the curve, you know that you'll write down dy here. And here that something, that equation would be in terms of y. Initially, it is not in terms of y, it is in terms of x. In order to find the equation in terms of y, you need to make x the subject, okay? And when you'll make x the subject, this is what you're gonna get, right? So this is what we have discussed already. This, we obviously did more questions for this because this is the scenario, this is the case, like this is a repeated case every time we are integrating and finding the area between the x-axis and the curve. But I am pretty sure that we discussed this as well. Okay. Okay, I'll explain this again. Please pay attention. This is important, and but it is easy, so don't worry about it. Okay, I'll rub the extra things that I've written. Okay. So let me explain this again. Okay, now please pay attention, all of you. Okay. Yesterday, the last thing which we were discussing was volumes of revolution. For now, I did not discuss this topic. So for some time, let's just forget this. I'm rubbing this and I'm talking about some old knowledge, okay? The old knowledge is about the area that is bounded between the curve and the x-axis and the area that is bounded between the curve and the y-axis. We are basically discussing how to write down the integrals for these two different scenarios. Okay, so let's talk about this scenario first. This is case one, and this is what we have been doing repeatedly. Here we have the area between the curve and the x-axis. So you know that the limits would be from the x-axis, that is 2 and 5, it would be dx. And when you have dx here, this thing would be in terms of x. So I'm pretty sure that you guys would be comfortable with this. For example, if I make another diagram quickly, let's say if I make this one, something of this type. This is 1, this is 3, and whatever the equation is, let's say the equation is y equals minus x square plus 1, okay? So in that case, again, you are going to integrate. The limits would be 1, 3. This is the area that you are interested in finding. You write dx and you write down minus x squared plus 1. Any confusions for this thing? Everything that is written on the right side of this curved line? Any doubts with this? No, okay. Ishal and Munja, what about you?
I'm okay, thank you, ma'am.
Okay, very good. So we are comfortable with this concept because we have been using this repeatedly. Okay, very good. Now let's talk about the new scenario. This thing. Okay. What is the difference in case 1 and case 2? The difference is that in case 2, the area is bounded between the y-axis and the curve. Okay. That is the difference. Obviously, if this is the difference, things would be different in the integral as well. The limits are coming from the y-axis. Okay, we write down dy here. Now, if you're writing dy here, and if I write down x squared here, this would not make sense. Okay, you need to integrate with respect to y. For that, the variable should be y here. So, what is the only difference? You will make x the subject just so the equation is in terms of y. When I'll make x the subject, I'll take under root on both sides. It would become under root y equals x, and I will write down under root y. And now it is your win-win situation. Now you know that we can integrate this. Yes. Did you understand this thing, the difference between both these?
Yes, ma'am.
Okay. Ishal and Haris. Okay, what about you, Ishal? Okay, very good. Excellent. Okay. Now we are in the form. Now we can talk about the topic under discussion. Okay, so we were talking about volumes of revolution. Okay. What is going to happen in this case now? Okay. I'll tell you. For a second, I'm going to rub this. Please just focus on this part only. And I write down the integral here. So in order to integrate it, we do it from 2 to 5. We do x squared and dx. Okay, this is what we have just discussed. From where exactly this volume is coming? Now the idea is that if I rotate, if I revolve this shaded region to an angle of 360 degrees, what am I going to get? So I made this shape yesterday as well. Let me make it again. It's y, this is x, and it is going to be, just pay attention. What am I doing? I am rotating this shaded region to an angle of 360 degrees about the x-axis. Okay, so just imagine that I have this region and I'm flipping this. I'm rotating this to an angle of 360 degrees. So that is going to make a shape, something of this type. Not exactly this, but you get the point. Something of this type, right? So this is a 3D shape. And here we are basically discussing how to find the volume of this 3D shape. I repeat, in these questions, you'll have a shaded region, you'll have a 2D figure, you'll have area only, and you are going to see that how that area would turn into volume of a 3D shape, right? Did you understand this thing? That from where exactly this 3D shape is being made? This shape is being made using this shaded region. I am rotating this to an angle of 360 degrees, and this is what I'm getting. This is a bell-shaped thing. Okay, and what about you, Ishal and Munja? Please confirm.
Yes, ma'am. Thank you.
Okay, Ishal, did you understand this? Acha, okay. All right. Now, the thing is that how to find this volume of revolution. Okay. So just give me 1 second, please. I'll be back. Just give me 1 minute. Okay, I'm sorry, I'm back. Okay. So yes, we were talking about volumes of revolution. Okay, right. Now we know how to find the shaded region. For finding the shaded region, we need to integrate, okay? It is with respect to x and the limits are 2 and 5. How exactly we are going to find the volume? That is also going to be through integration, okay? So I'll tell you. You need to write down the same integral the way we have written initially, 2, 5, okay? X squared dx, okay? Next, we need to add two more things. So I'll add those things with a different color. We need to square this thing and we need to add pi. And that is it. You will integrate it, and once you integrate it, whatever you get, that would be the volume of revolution. Anything that you have not understood? Yes.
So far, so good.
Okay. Okay, I'll repeat this again. Okay. Okay, all right. Just pay attention again. That's okay if you have not understood this. All right. So I assume that you guys know how to find the area under the curve, right? How to find the shaded region. Okay, that is good. If you know how to find the shaded region, you can easily find the volume of revolution. I know that this shape is being made using this shaded region. I've rotated this to an angle of 360 degrees about the x-axis, and that is how I got the volume. Okay, I got this 3D shape. I'll write down that area again. Okay. I need to add two more things. I'll do that with a different color. I need to add pi, and I need to square this equation. And that is it. This is your new integral. You need to integrate it. And once you integrate it, whatever you are getting, that would be the volume of revolution. Yes. Did you understand this? All of you, Haris and Ishal, please confirm if this is okay or not. Okay. What about you, Ishal? Yes, Ishal, did you understand this? Please confirm. Okay. Let's talk about an example now. So that example would be from coming from case 2. Okay. This is the example. This is example number 2. Okay. All right. Let's talk about this example. So what exactly is the question? I will just write down the question. Okay. So I'll write down the question and we'll see. Okay. The example is, find the volume obtained when the shaded area is rotated through 360 degrees about x-axis. Okay, this is the question that we are going to do, and this is the shaded region. This is the last example for today. Please pay attention. This is the last thing. After this, we are done with integration and pure maths. So please stay focused. Okay. Find the volume obtained when the surface area, when the shaded area, I'm sorry, is rotated through 360 degrees about the x-axis. Okay. So this should be y-axis. Okay. All right. Now this is the example that we need to do. We did one example yesterday as well that was about rotating the area about x-axis. I'll share the recording so those who were not able to attend yesterday's class can watch them. But for this, please pay attention. This shaded area, this one would be rotated to an angle of 360 degrees about the y-axis such that a shape, a 3D shape would be made, and we need to find that volume. So how do we do it? Okay. We need to talk about the integral for finding the shaded area first. Okay. So this is case 2. You know that how we find the shaded area. We just write down the limits on the y-axis. We write down the equation in terms of y, and we write down dy. This should be clear. This is just what we discussed. Next, you need to square this equation and you need to add pi. That is it. Once you have this, you need to integrate it. Whatever answer you're getting, that would be the volume, right? Anything, any confusions, anything that you have not understood, please confirm. Yes, Munja, Haris and Ishal, please confirm if you have understood this or not. I'm waiting. Okay.
Oh, yes, ma'am. I've understood.
Okay,
We've
all
just
right.
finished, I
Okay.
think.
Now,
Yeah.
okay. Now let's just integrate it. So let's simplify the function first. Square and under root would cancel this. It would be 2, 5, pi, y, and dy. Okay. Next, I
Mm.
need to integrate it. How do we integrate it? We know that this is the most simple integral. I'll write down pi as it is. I'll write down y. I'll add 1 to the old power. I'll divide it by new power and I'll write down the limits of integration. Okay. So this would be pi y squared by 2. And again, I'm going to write down the limits. Please plug in the limits, find the difference and tell me the answer quickly. I'm waiting for your response. Yes. First, I'll plug in 5 by 2. Then I'll plug in 2. So it is going to be 25 pi by 2 minus 2 pi. Okay. And the final answer is going to be, I'll write it down there. It would be 21 pi by 2 units cubed, not square, cubed, because this is volume, right? So I'll repeat this one last time and then that is it. Here we're talking about volumes of revolution. So initially you will have a shaded area. You are going to rotate it to an angle of 360 degrees, either about the y-axis or about the x-axis. That would depend on your scenario, okay? I did not give you any difficult formulas to memorize. You should know how to find the area. If you know how to find the shaded area, you can easily find the volume, okay? Once you know how to find the shaded area, you need to add 2 more steps. Just add pi and square the equation. That is it. Okay. And now you just need to integrate it. So this integration is very easy. You know how to integrate it. You know how to plug in limits. And this is basically going to give you the volume of revolution. Yes. Any doubts in this? Anything that you have not understood in this class, please confirm. Yes, Manja and Haris, please confirm if this is okay or not.
Yes, ma'am. Thank you.
Okay. All right then. Okay. So I'm going to stop sharing this and I'll share another screen. I'll stop the recording.